Hello students, I am Kirti from Computer Science Department, GSIPU College, Mysuru. So in the previous session, we have studied about creating a node as well as traversal of a linked list. But in this session, we are going to study about the memory allocation for a linked list. Memory allocation to a linked list. Computer memory is a limited resource. Therefore, some mechanism is required to store the deleted nodes for future use. So, this computer system maintains a list called a while, where it is going to store only the unused deleted nodes. It is where we are going to store unused deleted nodes. So whenever the nodes which are no longer needed are deleted from the linked list is going to be stored in the while list. That memory space is going to be stored in the while list. Whenever we require a node to be inserted into the linked list, we are going to take that node to be inserted into the linked list from the while list. So this is the usage of a while list. So now let's see how to insert a node into the linked list. Inserting a node into the linked list at the beginning. That is, consider this start pointer contains the address of the first node and this first node contains some data and the link part contains the address of the next node, and the second node contains the data part in the first field, and in the link field it is going to contain null, which represents the end of the linked list. So now I want to insert a node at the beginning of the linked list. See, I want to insert an item called 30 to the beginning of the linked list. So how to insert? We have to follow some steps. First we have to create a new node, then we have to insert an item into the new node to the data part. Then for the link part we are going to write it as null here. So next, attach this newly created node to the start. So attach this newly created node to start. Then what we have to do? In the link part we have to give link to the next node of the linked list. Next node of the linked list. So now the new list will be like this. First it contains a node with information 30, then with the second node the information will be 10 and the third node will be 20. In the link part it contains null. This is how we are going to insert a node to the beginning of the linked list. So now let's write an algorithm for this. algorithm for inserting a node to the beginning of the linked list. To the beginning of the linked list. So what is the first step? First step, we have to create a new node. So let the new node be P. Let that new node be P. In step 2, I am going to fill the information in the data part of that node. Data of P. We are inserting a number to the data part of the new node. In step 3, in the link field of the new node, we are creating this new node as we are linking this new node to the start pointer. To the start pointer. In step 4, start pointer contains the address of the first node, that is P. It contains the address of the first node. Step 5, return. So what is the first step while inserting a node to the beginning of the linked list? First, we have to create a new node called P. In the data part of the new node, we are going to insert an item, that is a number. In the link part, what we are going to do, we are linking the first node to the start pointer, and the start pointer contains the address of the first node. So this is how we are going to insert a node at the beginning of the linked list. Now let's see how to insert a node at the end of the linked list. So while inserting a node at the end of the linked list, so first we have to create a new node. So in the new node, in the data part, we have to fill the number, and in the link part, we have to mention it as null, which represents the end of the linked list. Inserting a node at the end of the linked list. So consider a linked list. Start is a pointer which contains the address of the first node. So this first node has two parts, data part as well as link part. This data part contains the information and the link part contains the address of the next node. And in the second node, the first part contains information, second part contains the address of the next node. In the third node, it contains 30 as its information, and in the link part it contains null, which represents the end of the linked list. So this linked list contains only 3 nodes now. So what we have to do here, we have to perform the operation, that is inserting a node at the end of the linked list. So how to insert a node to the end of the linked list? First we have to create a node. So in the data part, I am going to insert an item called 40, and in the link part I am going to write it as null, which represents the end of the node. So now I have to create a link from the third node of the linked list to the newly created node. I have to create a link from the third node of the linked list to the new node. So here I have to remove this null and I have to create a link to the new node. So now let's see the algorithm for inserting a node at the end of the linked list. So algorithm to insert a node at the end of the linked list. So I am going to consider this new node as n and the first node with a pointer called p. So what is the first step? First step, we have to start to insert a node at the end of the linked list. So this first step, so the start contains the address of the first node, that is p. It contains the address of the first node. So the start contains the address of the first node p. So to insert an item at the end of the linked list, first we have to traverse all the nodes of the linked list to check the last node of the linked list. What is the meaning of traversal? Traversal is nothing but visiting each node of the linked list exactly once. First I am going to visit this node. I am going to access the data part as well as the link part. So if the link part is null, we are going to stop, that is we are going to consider it as the last node. If the link part does not contain null, we are going to traverse the next node. Here also we perform the same operation. If the link part does not contain null, then we are going to access the next node. So in here, before this insertion, the last node contains null, right? So the link part contains null. So we are going to stop the traversal. So we are going to consider this as the last node, as the link part of this third node contains null. So now what we are going to do, we are going to link this third node to the new node. So here we are going to check while p does not equal to null. That is, if the link part of the node does not contains null, means we are going to traverse for the next nodes in the list. That is next of p. So if I am going to traverse from this node to this node, then this node will become p. Understood? So until we get the null in the link field, we are going to traverse all the nodes in the linked list while end. So in the step 3, create a new node and copy the address to the pointer n. So now this new node we have created, so we are copying the address to the pointer n. In step 4, I am going to insert data into the data part of n. That is data of n. Data part of n, I am going to insert item. In the step 5, In the link field of the new node, I am going to insert it as null. So that is link of n will be null. So after creating this new node, what we have to do? We have to create a link from the last node to the new node. So now this node will be the P, that is pointer P. So we are creating a link to the new node, that is link of P. We are creating the link to the new node from the last node of the linked list. That is, in the link part of the last node, we are going to delete this null and we are going to create a link to the new node. Step 7, return. So this is how we are going to insert a node at the end of the linked list. First we are going to consider, that is, the start pointer contains the address of the first node. So consider this node as a pointer P. So here we are going to check until link part of the node gets null. So until the link part of the node gets null, we are going to traverse all the nodes in the linked list. When we get the null in the link part of the node, we are going to consider it as the last node of the linked list and we are going to stop traversing. And we are going to create a new node and we are going to copy the address of the new node to the pointer called n. In the data part of the new node, we are going to insert an item, and for the link part, we are going to insert it as null, which represents the end of the node. So after filling these two details, we are going to link the new node to the last node of the linked list. So now let's see what is garbage collection. What is garbage collection? If a node is deleted or the linked list is deleted, so that deleted memory space is required for future use. So that deleted memory space is reinserted into the free storage space for future use. So this technique of restoring the deleted memory space is called as garbage collection. So now let's see how to delete a node from the beginning of the linked list. Deletion of a first node, deletion of the first node. So it is easy to delete the first node in the linked list. First we are going to copy the data of the first node and then we are going to link the second node to the start pointer. But if the linked list contains only one node, then the start pointer contains null after deletion of that node. So see here, the start pointer contains the address of the first node and this first node contains the address of the second node and the second node contains the address of the third node. So the link part of the third node contains null, which represents the end of the linked list. So now we are going to delete the first node from the linked list. So how to delete? First we have to copy the, let this pointer be P. So first we have to copy the data of this node. What is the first step? Then we are going to create link to the second node of the linked list, and we are going to free this node. So let's see how to write an algorithm for this. The first step is start, and second step is, so the start contains the address of the first node. It contains the address of the first node. So we are going to copy the information of the node, print data of P. Next, what we have to do? We have to create a link to the second node of the list. Second node of the list. Step 4. So now this becomes P. So we are going to link this second node to the start pointer. So in step 5, we are going to free this first node. Free P. Step 6, return. So while deleting the first node from the linked list, first we have to copy the data of the node. Then we have to create a link of the second node to the start pointer, because the start pointer contains the address of the first node. So we are going to delete this first node itself. So we have to create a link from the start node to the second node of the linked list. Then we have to free this first node. So now the linked list contains only two nodes. That is, start contains the address of the first node. Now this node, second node, becomes first node in the linked list. And this contains the address of the next node. So now the linked list contains only two nodes. If the linked list contains only one node, so if I want to delete this node itself, means then I am going to free this node. So now the start pointer contains only null. Only null. This is about deletion of the first node. Now let's see how to delete the last node in the linked list. So now let's see how to delete a node at the end of the linked list. Delete a node at the end of the linked list. So while deleting a node, so the start pointer contains the address of the first node. So this first node, in the link part, it contains the address of the next node. So this linked list contains 4 nodes, and the last node contains null in the link field. So while deleting a node at the end of the linked list, so how to find the end of the linked list? if a node contains a null in the linked field, then we are going to say it as the last node of the linked list. So this is the last node and this is the second last node. Second last node. First we have to find out the last node as well as the second last node of the linked list. So here we are using two pointers, P1 and P2. P1 and P2. So P2 is used for traversal of all the nodes in the linked list and P1 is used to store the location of the previous node. So now first the start contains the address of the first node. So we are going to traverse from the first node of the linked list. So I am going to use the pointer called P2 for traversal. First I am going to traverse the first node. So this node does not contain null in the link field. Then I am going to traverse for the second node. So this node becomes P2. So the first node of the linked list becomes P1, which contains the address of the previous node. So here also in this node it does not contain null value. So I am going to traverse the third node of the linked list. So this also does not contain null as its value in the linked list. So in the last node it contains null as its value in the linked list. So I am going to consider this as the last node and this will be the previous node, that is the second last node. So while deleting, first I have to remove the link from third node to the fourth node. So in the third node, I am going to write it as null and we are going to free this last node. So now let's write an algorithm for this. Step 1, start. Step 2, so the start pointer contains the address of the first node, that is pointer P2. It contains the address of first node, that is pointer P2. In step 3, while link of P2 does not contains null. If the link of P2 does not contains null, what we are going to traverse all the nodes in the linked list until we get null as the value in the link field of any node. So that is, now this node becomes P1. So P2 becomes P1 and P2 contains the link of next node. So now this becomes P1 and the next node of the linked list becomes P2. So this will continue until we get null as the value in the link field of P2. While end. Step 4. So here we got null as a value in the link field of the node. So we are going to print the data of this node, data of P2. In step 5, we are going to fill null in the link field of the second last node, which is nothing but P1. That is, link of P1 is going to be null. Free P2. Step 6, stop. So while deleting a node from the end of the linked list, first we have to find out the last node as well as the second last node in the linked list. And here we are using two pointers, P1 and P2. P2 is used for traversal and P1 is used to store the location of the previous node. So the start contains the address of the first node. So this first node is considered as P2 initially, while link of P2 does not is equal to null. We are going to traverse all the nodes in the linked list. So while traversing, this previous node becomes P1 and this P2 contains the link of the next node. So we are checking for the next nodes. So until we get this null value in the link field of the node, we are going to traverse all the nodes in the linked list. When we get this null value in the link field of the node, we are going to print the data of this node, and for the previous node, that is P1, in the link field we are going to fill the value null and we are freeing the last node of the linked list. So in this session we have discussed about the memory allocation for linked list, insertion of a node from the beginning of the linked list as well as the end of the linked list, deletion from a node from the beginning as well as end of the linked list. So in the next session I will come with a new concept. So thank you.